Let's talk about the variation of acceleration due to gravity. The value of acceleration due to gravity changes with height, with depth inside the earth, with the shape of the earth, as the shape of the earth is not spherical, it is oval. That means the polar diameter is less than the equatorial diameter. It is somewhat flattened at the equator. We are going to discuss the variation of g with altitude, with depth, and with the shape of earth. Let's take the variation of g with altitude. The earth, taken as a uniform sphere here of radius r, at the surface of the earth, the value of acceleration due to gravity g is gm by r square, whose value is 9.8 meters per second square. Let us calculate the value of acceleration due to gravity at a height h. Let that be g dash, but remember this h should be less than r. Here at this point the distance from the center of earth is r plus h, so we can show that g dash is equal to gm by r plus h whole square. Now let this be 1 and let this be 2. Dividing second by first, we have that g dash divided by g is equal to gm by r plus h whole square into r square divided by gm. Here gm and gm cancels out, so we can show that the numerator is r square divided by, if we take r common, when we take r common out of the bracket, that comes as r square because it has whole square. So r square into 1 plus h divided by r whole raised power 2. So r square and r square goes. If we take this denominator to the numerator, the power becomes minus, so that becomes 1 plus h divided by r whole raised power minus 2. When we expand this by binomial theorem and neglect the higher powers because the value of the higher powers is less here, so we can show that g dash divided by g is equal to 1 minus 2h divided by r. So g dash is equal to g into 1 minus 2h divided by r. So this is the value of acceleration due to gravity at an altitude h. So we can show that when we multiply this g dash value will be g minus 2hg by r. That means there is a decrease of 2hg by r from the value of g. So with height, the value of acceleration due to gravity decreases. Now, as already explained, g dash is equal to g into 1 minus 2h divided by r. So g dash is equal to g minus 2hg divided by r. Decrease in value of g is equal to g minus g dash, that is equal to 2hg divided by r. So this is the decrease in value of g. Fractional decrease is equal to g minus g dash divided by g, that is equal to 2h divided by r. This is decrease in value of g. This is fractional decrease in value of g. Calculating the percentage decrease in g, percentage decrease in g will be equal to g minus g dash divided by g into 100, that will be equal to 2h by r into 100. This is percentage decrease in the value of g. An important point, this equation, that is g dash is equal to g into 1 minus 2h divided by r, this equation is valid when h is less than r. If the height is comparable to r, that means if h is equal to r, h is equal to 2r, h is equal to 3r, h is equal to 1.5r, that means the altitude is comparable to the radius of the earth. In that case, the value of g dash there will be got by. So g dash is equal to gm divided by r plus h whole square. Now if h here is equal to r, that means here h is equal to r. From the surface of earth it is at a distance of r, or from the center of earth it is a distance of 2r. In that case we will see g is equal to gm by r square. Here we will substitute this gm will be equal to gr square. In that case our g dash comes out to be gr square divided by r plus r whole square, that is equal to gr square divided by 2r whole square, that is 4r square. So r square and r square cancels out, so that will be equal to g by 4. That means when the heights or the altitudes are comparable to the radius of the earth, we are gonna use this equation, that is g dash is equal to gm by r plus h square. We will substitute the value of gm as gr square and we will get the value. Thank you.